Hello again, our most valued student. My name is Confident and welcome to AgroLenTech's 24-minute lesson. Our lesson today will focus on exponents, surds, and logarithms. This lesson will continue into other videos, but for today we will look at exponents. Then in the other videos we'll look at surds as well as logarithms. Now, when we're looking at an exponent, when we're talking about an exponent, what do we mean? The first thing that you'll notice is, you will notice just before the exponent there is this number with a sign. So this is the number with a sign. So number and sign, that is before the exponent. It can be positive also, it can be negative, it does not matter, but it affects the exponent. And then you look at that 2, we say that 2 is a power. And then we look at a, that a is a base. So it's a to the exponent of 2, a means the base. And then when you look at this whole part together, we call that the exponent. That's what we mean by the exponent. So when we're dealing with an exponent, there are certain laws that you must know. We have got 11 laws altogether that we're going to go through as quick as possible. So let's get to each and every law so that you might understand the laws of exponents. When you master these laws of exponents, you will discover that it will be easier for you to interlink them, because the trick and what the most questions are looking for in the examination is, can you interlink and interchange them and make them to your advantage? Now let's look at the first law. It says a to the power m times a to the power n. Now in other ways, when they're saying a, let me use the red one, a to the exponent of n times a to the exponent of n is equal to. What must you notice? Number 1, there must be a multiplication sign. Number 2, the bases must be the same. So if the base and the base are the same and there is a multiplication sign, then the law is applicable. What must you do? You write the base and then you add the two exponents. For example, xy times x squared y cubed. Now you do the same thing, whereby you say xy times x squared y cubed. Look again at the bases and the exponents. You have got x and x, and you have got y and y. So those are two bases. Let's start with x. You're going to have x. When you don't see any number, it means there is a 1 and there is a 1. So the first one is like you have got the base of a, the base of x. You have got 1 plus the other one, there is a 2 there. So it's 1 plus 2, and then you write y. Again, y is 1 plus 3. Then the final answer will be x to the power 3, y to the power of 4. That becomes the final answer. What about the other one? If you are given a, 2x plus y times a to the power of 3x plus 2y. When they give you this kind of an exponent, also you are still using the first law. The bases are the same, so you're going to have a. Now you're going to have 2x. You collect like terms, plus 3x plus y plus 2y, which is equal to a. 2x plus 3x, it's 5x, plus y plus 2y is 3y. That is the final answer. So that is the first law. Now the next law is talking about a to the exponent m divided by a to the exponent n. Now again, what do you notice? The bases are the same, but now we have got a division sign. When you've got a division sign, you can see that in a division sign there is the minus sign. This minus sign in a division sign. So it's just a hint to tell you that whenever you're dividing, it's a minus n. You know, the minus of a division sign will remind you that you also put a minus in the exponents. Now, for example, the example that we're given here, x y divided by x squared y cubed is same as, remember when there is x, it means it's x to the power 1. Because it's divided to say 1 minus 2, the basis of x, and then y to the power 1 because there is a 1 there, and then it's 1 minus 3. So you're going to have x 1 minus 2 is minus 1, y 1 minus 3 it's negative 2. The next one is 21 x to the power 4 divided by 3x squared is equal to, now whenever you're given a scenario like this, first consider the numbers. So what you're going to have is 21 over 3, because divided means over 3, and then you write your exponents, which is x to the power 4, you apply the law, same base, so it's 4 and it's division sign, which means minus 2, which is equal to 21 divided by 3, it's 7x, 4 minus 2, it's 7x squared. The next law, a to the power m, n is equal to a to the power m, and in other words they are saying a to the exponent of n, there is a bracket, is equal to a to the exponent of m times n. You multiply whenever there are two exponents separated by this bracket. When you see a bracket and there are two exponents, they multiply each other. Now, given an example, when they say x to the power negative 2 to the power 4 is same as x to the power negative 2 times 4, which is equal to x to the power minus 2 times 4 is minus 8. Another one, another law, they are saying a b to the power m, this is the fourth law, is equal to, now remember this one, I said there is a power 1 and a power 1, so this m is more like you are saying a to the power 1 times m, b to the power 1 times m. It affects each one of them, which is a to the power 1 times m is m b to the power m. I want you to notice the difference between the two. If you go back to the top one here, m times n also is m as a to the power m n. Now I want you to notice the difference in here. When you see this bracket, and you can see a is inside the bracket and b is inside the bracket, it means this m is affecting both a and b, hence it's am bm. Given an example, for example, they are saying x to the power negative 2, y to the power 3, multiplied with 4. This is equal to 4 times minus 2. It's x to the power minus 4 times 2, y to the power 3 times 4, which is equal to x to the power minus 8, y to the power 12. That is how you can solve that. What about the other one? I'm going to erase the top things that we did because I want to show you the other one. If we look now at the other example of the same law, which says, I'm looking at this example here, 2x squared to the power 2 and then times 2x squared. I want you to take note of the analysis. Now this power 2 here, let me not erase it but just round it nicely, it's affecting that and affecting the x, but now this power 2 is only affecting this x, not the 2. Do you see how the brackets are influential? Why is this 2 affecting that, this x and the 2? Because of these brackets. Now because of those brackets, everything inside is affected, but here in the second scenario we don't have brackets, hence this power 2 is only affecting x. So how do you work about it? This is same as 2, remember there is a 1 there, it's 1 times 2 x, 2 times 2 times 2x squared, which is equal to 2 1 times 2. If you use a calculator, you will get 2 squared is 4, x to the power 4 times 2x squared, which is equal to, now you look at numbers, you multiply numbers alone. 4 times 2, you get 8. Now you apply the law on the exponent, x to the power 4 plus x to the power 2. Remember, it's 4 plus 2. And then when you finish it up, what you're going to have is, you're going to have something like this, which is equal to 8x to the power of 6. That is that law. The law number 5, it's similar to the previous law. If a over b to the exponent m, because of the bracket in here, that's why a is alone affected and b is alone affected. That's why they gave you there x squared over y cubed to the power of 4 is the same as x 2 times 4 over y 3 times 4, which is equal to 2 times 4, x to the power 8 over y to the power of 12. The next law that we're looking at here is 1 over a to the power m. This is very important. Now, whenever you're simplifying this, we have not been continuing, we're leaving our answers with a negative exponent. Now, whenever you're given something like this, it means when you see the division sign over, now I'm going to use another pen. For you to take it and remove this division sign, you are going to write it as a to the power negative m. So this negative m is a way of removing the division sign. Please remember, meaning if they give you a to the power minus m, if you want to put again to remove this negative sign, if you want to remove that negative sign, you're going to say equal to 1 over. 1 over, it works together with the negative sign. 1 over what? 1 over a to the power m without the negative sign. Hence, here when they are saying 1 over y to the power 4 is same as, when you simplify it, you want to remove this 1 over and you want to take it on top. So it will become what? Y to the power negative 4. I'm just trying to separate that. That is the law. Let's look at the next law. It's 1 over a to the power minus m. So now this one is 1 over. Now remember, a to the power negative m from the previous one is same as 1 over a to the power m. Now because of these two 1 over, these two 1 over, this simplifies to a to the power m. That's how it's like. It becomes the 1 divided by 1 is a 1 and the a to the power m goes on top. So that the quicker way though is to just jump from 1 over a to the power m, you just jump to this answer. Why? You have got 1 over and a to the power m is another 1 over, so you just go to this top. Hence, if they give me 1 over 2 to the power negative 4 is equal to, because of this over and because of that negative, I just write 2 to the power 4. 2 to the power 4, which is 2 times 2, 4, 4 times 2, 8, 8 times 2, which is 16. That's how you can simplify. Another one also, another law that we can apply, if I can erase this, if you can look at this law, it says a over b to the power negative m. If I do it the long way, it's 1 over a over b to the power m. You see, by saying 1 over, I was getting rid of the negative by putting 1 over. Now when you have got that, this is same as 1 over a to the power m over a to the power, b to the power m, which is equal to 1 divided by a to the power m over b to the power m, which is equal to 1 times, remember when I times, I interchange what was on top goes there, what was here comes down, which is 1 times bm over am. So the answer becomes bm over am. So hence it's that answer. But when you're given in a scenario, they just say a over b to the power negative m. Because you don't want to go through that whole stage, you just interchange. The bottom becomes on top, which is b over a to the power m. Then you can simplify that further. Hence, when they give me a scenario or a problem like this one, whereby they say, if I can quickly go through that, if they say 3 over 2 to the power minus 3, which is equal to, if I do the long method again, it will be 1 over 3 over 2 to the power 3, which is equal to 1 over 3 to the power 3 over 2 to the power 3. Now, which is equal to 1 over, what is 3 to the power 3? 27 over 2 to the power 3 is 8, which is equal to 1 divided by 27 over 8, which is equal to 1 times 8 over 27, and the answer is 8 over 27. Do you see that is a long route to get that? But now, if I'm doing it the quick way, I can quickly do that one the quick way, whereby I'll say 3 over 2 to the power minus 3. This will be equal to 2 over 3. The bottom goes on top, the top goes bottom, to the power 3, which is equal to 2 cubed over 3 cubed. What is 2 cubed? It's 8 over 3 cubed is 27. Look how quickly it can happen without going all the long stage. So the main aim is to finish the exam in time. The next law of laws of exponents, it says, if you are given that with an NA, what does it mean? It means this is same as equal to. Now, there is a power 1 that is hidden there. So because of that power 1, it's same as A to the power 1 over N. That is the power 1 that was given. It's 1 over n. And just to give you a quick hint, when they just do this and they say 2, this is same as, what is hidden is there is a 1 there and there is a 2 there. They don't usually put these numbers. So this is the same as 2 to the power of half. I'm just giving you a way ahead trick there. So now, when you look at this one, which is so now if you look at this one, which is 5, it means 5th root of 2x. This is same as I mentioned. Now if you can put a bracket, there is a 1 that is hidden there, so now it will be same as 2 to the power x. Now you put that bracket and say 1, this 1 over a 5. This 5 always go at the bottom, is 1 over a 5. And then you'll simplify that. The number 10, it's similar. If they give you that 3, I'll just go quickly to the question. What you can see here, look at it. Remember, this is same as, it's x to the power. This first 3 is the one that goes below, and this 3 is the one that goes on top. Do you see how it's like? And then this become, which is equal to x, 3 divided by 3 is a 1. And then when they give you another scenario here, if I can show you another scenario here. Another scenario here is they gave that 9x to the power 4. And then if you still remember, the hint is that when they didn't give you any number, you must know that there is a 2 there, and then it's 9 x to the power 4. This is equal to, Now remember, this is at the bottom, it becomes 9x to the power 4, and then when you do that, remember 2 is the one that is at the bottom, and then here 9x to the power 4 all together, because they are all together, there is a 1 representing them. Then this is equal to, then what you're going to have here is 9. Remember, 9 is 3 squared x to the power 4, which is equal to, sorry, that's not the one, I must put a bracket, not forget my half, which is equal to, remember this other law now they're coming into use, 3 squared times half times x 4 times half. We are now multiplying like the previous, you are opening up. 3 times half, which is 3 to the power 1 x to the power 2. This is 3x squared to the power 2. And when you look at the last law that they are given there, before we look at other problems, what is the last law that they gave us? They are saying the last law is a to the power of 0 is equal to 1. Any number to the power of 0 is equal to 1. If they give you 1000 to the power of 0, it's 1. Hence, this number 3xy over 4xy squared. The moment you put a bracket and say to the power 0, it means everything to the power 0. You simply get a 1. Now, let us use the laws to strategically solve these problems. Now, we are given ab squared. If you analyze ab squared there, you will see that the 4, let me write it again, ab squared 4 times a squared b cubed 2 all over a 3b times a b to the power 4 is equal to, now I'm analyzing, this 4 is affecting this b squared and affecting that a squared, and this 2 is affecting that b3 and affecting the a squared, and this 4 is affecting the b and affecting the a, and the 3 here is only for a, the 3 here is only for a, not for b. So when you simplify that, the first one, if I can erase so that it's clear. Oh, sorry for that. Forget about the errors. If I can now go and solve this, if you can just try to look it through the errors, what I'm having is a to the power 1 times 4, b to the power 2 times 4, and then times a to the power 2 times 2, b to the power 3 times 2, all over a to the power 3, b to the power 1, because if there is nothing, there is power 1, and then a to the power 1 times 4, b to the power 1 times 4. That's simple what it means. Quickly, you are going to have 1 times 4 is 4, so a to the power 4, b to the power 8 times a, 2 times 2 is 4, b to the power 6, all over a to the power 3, b to the power 1, times a to the power 4, b to the power 4. Now, this is equal to, you are now, 2 options you can do here, but I'm going to quickly show you because of time, and then we'll continue this one in the next session. You are going to add a to the power 4, they are multiplying, so you add them. This is below is dividing, you subtract it. This is below, you divide it. Same thing with b. The top ones will multiply, you add. The bottoms one, they are dividing, you subtract, and then you give a final answer. Let's continue this one in the next session. We have come to the end of our lesson. Thank you again.